Today we're going to be covering L'Hôpital's rule. Okay, it's pronounced L'Hôpital's, not El Hospital. Don't be a math degenerate and pronounce things weird on purpose. It's Riemann, not Riemann. It's Euler, not Euler. And it's L'Hôpital's. The amount of people who say El Hospitals, it's kind of funny. If I were to take the limit as x goes to 0 of sine x over x, I would, first of all, try direct substitution. What's sine of 0? It's 0. What's 0? It's 0, okay? And now I have a 0 over 0 indeterminate form right here, okay? So before we knew how to take derivatives, we had no way of solving this limit. Your teacher may have forced you to memorize the actual answer to this limit, but memorization is not how we go through math. Okay, we need to understand why things are true. The criteria to use L'Hôpital's rule is you need to have an indeterminate form. You need to have 0 over 0, or you need to have infinity over infinity. Okay, 1 over infinity, that's an 8. 1 over infinity is not an indeterminate form, that's 0. Infinity over 1 is not an indeterminate form, that's infinity. Okay, so the indeterminate forms we're looking for are 0 over 0 or infinity over infinity, and the other ones are really rare, but you just need an indeterminate form. Now that we've verified our condition, now that we have an indeterminate form, what we can do is we can say the limit as x goes to 0, or as x goes to whatever, of sine x over x is equal to the limit as x goes to 0 of the derivative of sine x over the derivative of x, okay? So pay attention to what I'm doing here. I'm not using the quotient rule. I'm not doing low d high minus high d low all over low squared. I'm taking the derivative of the top, and it stays on top, and I'm taking the derivative of the bottom, and it stays on the bottom. So let's continue with the example. Equals the limit as x approaches 0 of what's the derivative of sine x? It's cosine x. What's the derivative of x? It's 1. Let me try and do direct substitution now. What's cosine of 0? It's 1. This comes over, it's all over 1. So my limit now is 1, and I'm able to solve my limit, okay?